Introduction to group. Let us see the definition of group. A group G is a collection of elements together with a binary operation which satisfies the following properties: closure, associativity, identity, inverse. A binary operation is a function on G which assigns an element of G to each ordered pair of elements in G. For example, multiplication and addition. Classification of groups. Groups may be finite or infinite. That is, they may contain a finite number of elements or an infinite number of elements. Also, groups may be commutative or non-commutative. That is, the commutative property may or may not apply to all elements of the group. Commutative groups are also called abelian groups. Let us see the properties of a group. Closure property. If we combine any two elements in the group under the binary operation, the result is always another element in the group. For example, the integers under addition, 1 and 2 are elements of Z. The addition of 1 and 2 is 3. 3 is also an element of Z. Counter example, the odd integers are not closed under addition. For example, 3 and 5 are odd integers, but the addition of 3 and 5 is 8. 8 is not an odd integer. Property of associativity. The associative property, familiar from ordinary arithmetic on real numbers, states that A into B into C is equal to A into B into C. This may be extended to as many elements as necessary. For example, in integers, A plus B plus C is equal to A plus B plus C. In matrix multiplication, A star B star C is equal to A star B star C. Property of identity. The identity property, familiar from ordinary arithmetic on real numbers, states that for all elements A in G, A plus E is equal to E plus A is equal to A. For example, in integers, A plus 0 is equal to 0 plus A is equal to A. Here 0 is the identity. In matrix multiplication, A star identity matrix is equal to identity matrix into A is equal to A. In general, the identity is unique. There is only one identity element in any group. Property of inverse. The inverse of an element combined with that element gives the identity. Inverses are unique. That is, each element has exactly one inverse and no two distinct elements have the same inverse. For example, in the set of all integers under addition, the inverse of x is minus x. Thank you.